Hi, I'm Ms. Vung. Let's explore further symmetry properties. First, let's have a look at complementary relationships. Let's explore cos pi on 2 plus theta and sine pi on 2 plus theta. Recall in the unit circle that if we have a point for theta, it will look something like this. Now, if this is the point at theta, where would it be at pi on 2 plus theta? Well, pi on 2 is over here, plus theta, it will be over here. What do we notice about these 2 points? Now, recall that sine theta equals your y and cos theta equals your x. Now, so that means this line over here, that would be my cos pi on 2 with plus theta. That line over there looks exactly the same as that distance over there, except we know cos here is negative and sine here is positive. So cos pi on 2 plus theta, so the cos of this, would be the same as this sine of theta, but this is the negative of that, so we'll have a negative in there. What about sine pi on 2 plus theta? That would be this line over here. That looks the same as the cos of theta. So sine pi on 2 plus theta is the same as cos theta. So notice that cos is negative for the pink line, so therefore we have a negative in that expression there, equation there. What about when we do pi on 2 minus theta? So if we had that point again, well, pi on 2 minus theta would be pi on 2 minus theta would be over there. So let's find some patterns this time. We notice that the cos of pi on 2 minus theta is the same as the sine of pi on 2, the sine of theta. And we also notice that both of these values, cos is positive here and sine is positive here. So they're both positive. And the sine of pi on 2 minus theta is the same as the cos of theta. So you'll have to memorize these 4 statements. Cos pi on 2 minus theta, sine pi on 2 minus theta is the same as the sine and the cos, but cos pi on 2 plus theta is equal to the minus sine theta. And we saw because cos here is negative and sine here is positive. So it's not very hard to remember. Remember, complementary means 90 degrees minus, or pi on 2 minus or plus. And now we have a negative to be careful of. So let's do some examples. If sine theta equals 0.5, what is cos pi on 2 plus theta? Well, we know that from these 4 formulas that we have memorized that cos pi on 2 plus theta is equal to the negative of the sine. So whatever that sine is, which is 0.5, then that will be the negative of that. So therefore, we have cos pi on 2 plus theta is just simply negative 0.5. Example 2, if cos x equals 0.4, what is sine of pi on 2 plus x? Well, we know that sine pi on 2 plus x is just equal to cos x from this statement here. So therefore, we can just say that 0.4. So you have to memorize these 4 statements. Example 3, if x is between 0 and pi on 2 and sine x equals cos pi on 3, find x. Now let's write this statement out first. So we have sine x equals cos pi on 3. Now x is between 0 and pi on 2. What does that mean? That's in the first quadrant. So these 2 are in the first quadrant, these 2 are in the second quadrant. So if we're in the first quadrant, what is cos of theta equal to? Cos of theta is equal to sine of pi on 2 minus theta. So cos of pi on 3 is equal to sine of pi on 2 minus pi on 3, like so. And now that we have sine and sine, we can equate and say x is equal to pi on 2 minus pi on 3. And a half minus a third, a half is 3 over 6 minus 2 over 6. That would be 1/6 or pi on 6. If y is between 0 and 90 degrees, again we're in the first quadrant, and cos y equals sine 74, find y. Again, in the first quadrant we're dealing with these. So sine 74, sine theta, so that one there, is equal to 90 minus beta. So that would be cos 90 minus 74. We're using this statement over here. So you always look at which quadrant are we in, and then you can use the one of the equations there. So now that we have cos on both sides, y is equal to 90 minus 74, which is 16 degrees. Let's have a look at another symmetry property. So we have a point here on the unit circle. Now, if we have that point, we know that this is sine and that is cos. But we also know that the radius of the unit circle is always 1. By Pythagoras theory, we know that this side squared plus that side squared equals that side squared. But 1 squared is just 1. Or in other words, 1 is equal to sine squared theta plus cos squared theta. So memorize this statement now. Example 5, find sine theta if cos theta is 0.75. So if you have to find sine or cos and you have the other one, then we can use that statement to solve. So sine squared plus cos squared equals 1. So cos theta is equal 0.75. So cos squared is equal to 0.75 squared. So now we have, bring the 0.75 squared over the other side. We have sine is equal to plus or minus the square root of 1 minus all of that. Or if we plug that into the calculator, it would be plus or minus 0.661. Don't forget your plus or minus whenever you square root. Example 6. This is the last example, so bear with me. If sine theta is equal to 0.6 and theta is between pi on 2 and pi, so which quadrant are we in now? We're in the second quadrant. Find cos theta. Now if I have sine theta, then cos theta will be sine squared plus cos squared equals 1. We're going to use that. So sine theta is 0.6, so put 0.6 in here. Bring the 0.6 to the other side, square root both sides, and don't forget your plus or minus. Now we have cos is equal to 0.8 or negative 0.8. And because we have our domain to be in the second quadrant, then we know that it has to be negative 0.8. Cos is negative in the second quadrant. That is not a solution. So remember the statements you used to do for, let's say, when we're doing measurements of lengths, and we said a length has to be positive, therefore the answer is, well, we have to do that here. So the domain, the angle has to be in the second quadrant, therefore the angle must be negative because we're doing cos. What about tan theta? Well, we know tan is sine over cos, and we have sine and we have cos. So now we have 0.6 over negative 0.8, and therefore tan is negative 3.4, or otherwise negative 0.75. So you see there's a few symmetry properties we have to memorize and identify. So you always think, okay, if I have sine and I'm giving cos, so if I have a value for sine and want to find cos, or the other way around, then it's probably using the sine squared plus cos squared equals 1. I skip the word theta when I read this, but you know what I mean. But if I'm looking at something to do with the first or the second quadrant and I want to go from cos to sine, then I'm probably using one of the other two complementary angle identities. And lastly, if I have tan, then it's usually sine over cos. Alright, thank you for watching. I would suggest that you retry these examples without looking at what formula to use and see if you can use the right formula. Okay, bye!